What is the value of t, given that you have t to the power of 2 equals 16 to the power of 2? Then from here, because we have t to the power of 2 equals 16 to the power of t. Then from here, let's raise the power of both sides by 1 over t. So we have t to the power of 2 in parentheses to the power of 1 over t equals 16 to the power of t in parentheses to the power of 1 over t. So from here we have, to recall, when we have a to the power of m to the power of 1 over n, this can be interchanged as a to the power of 1 over n in parentheses to the power of 1 over m. So we are going to have this as t to the power of 1 over t to the power of 2 equals 16 to the power of t over t. So we have t to the power of 1 over t to the power of 2 equals, this divided by this will cancel, we have 16. Then from here, let's raise the power of both sides by 1 over 2. So this implies we have t to the power of 1 over t to the power of 2 times 1 over 2 equals 16 to the power of 1 over 2. So this will cancel out this. We have t to the power of 1 over t equals 16 to the power of 1 over 2. Then we can have 16 as the product of 4 times 4, which equals 4 squared. So from here we have t to the power of 1 over t equals 4 squared to the power of 1 over 2. So we have t to the power of 1 over t equals, from here we have 4, this will be 2 over 2. So from here we have t to the power of 1 over t will be equals 4 to the power of 1. Here we have t to the power of 1 over t equals 4. Then let's use W Lambert function to solve this problem. W Lambert function. But before that, let's introduce natural log ln to both sides. We have ln of t to the power of 1 over t equals ln of 4. So we are going to have from here 1 over t times ln of t equals ln of 4. This guy here, we can have it as t to the power of minus 1 times ln of t equals ln of 4. Then from here, let us recall that when we have e to the power of ln of a equals a, and this implies when we have e to the power of ln of t to the power of minus 1 equals t to the power of minus 1. So this guy here, we can now have it as, or let's have it here as ln of t times e to the power of ln of t to the power of minus 1 equals ln of 4. Then when we have e to the power of ln of a to the power of minus 1 equals as e to the power of the minus will come down to base here, then ln of a. So coming to here, we have ln of t times e to the power of minus 1 ln of t equals ln of 4. Mind you, we can have 4 as 2 to the power of 2. So here, before that, we have negative here, we have positive here. We want to make sure that the base here equivalent to the power that we have here. So we are going to have, let's multiply through by minus. So here will be minus ln of t times e to the power of minus ln of t equals, from here, we have minus ln of 4. So we have minus ln of t multiplied by minus ln of t equals minus ln of 2 to the power of 2. When we have ln of a to the power of m equals m times ln of a. So we have minus ln of t multiplied by e to the power of minus ln of t equals minus 2 multiplied by ln of 2. Then to introduce what we call W Lambert function, the theorem says when we have the W Lambert function of a multiplied by e to the power of a, this equals a. So far the base and the power are the same. So applying it here, and that is the main reason why we are trying to make sure that the base here is equivalent to this power here. So we have to introduce the W Lambert function as the W Lambert function of minus ln of t e to the power of minus ln of t equals the W Lambert function of minus l minus 2 multiplied by ln of 2. Then this will be minus ln of t equals the W Lambert function of minus 2 ln of 2. So far the base and the power are the same. From here, let's multiply 2 by minus. So here will be minus into minus ln of t. Here will be minus W Lambert function of minus 2 ln of 2. So here will be ln of t equals minus W Lambert function of l minus 2 ln of 2. So from here, there's a relationship between natural log and the exponent. They normally cancel each other. So we have e to the power of ln of t equals minus e to the power of minus W Lambert function of minus 2 ln of 2. So this guy, you cancel out this guy, we have t e to the power of minus W Lambert function of ln of minus 2 ln of 2. So at this junction, when we have this, we can have t as 1 over e to the power of W Lambert function of minus 2 ln of 2. And this is the final answer for the value of t. So if you are new here and you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos.